And welcome, folks, to another episode of our videocast series, Beyond the IT Headlines. In this series, we always go beyond the press releases and explain what's really happening in the world of IT and data, and more specifically, what it means for your business. We publish these bi-weekly and always focus on pushing the narrative beyond the headlines. With different guests and provocative points of view, I'm Shawn Rosemarin, and it's a pleasure to be with you this week. Today's topic: AI's power draw isn't just a data center problem. It's actually becoming a societal tension point. To scale sustainably, leaders have to rethink efficiency, power allocation, and the AI pipeline itself. To help us break it down today, I'm absolutely ecstatically happy to introduce Don Kirouac. Don, why don't you introduce yourself to our audience?
Hey, Shawn. Thanks for inviting me. I'm Don Kirouac. I'm the technical lead for product sustainability at Pure Storage.
All right. So, Don, you've got a lot of experience in the space. We're going to jump in. But look, at the end of the day, I think there's a lot of talk globally about how AI is going to save the world, how it's going to replace humans, how it's going to give us the next element of productivity. And I think there's truth to all of that when we take a long-term lens. But what we're going to focus on today is this actually going to break our power grid first? And is that really where we should be concerned about? And what are some of the considerations? So just to bring our audience up to speed, I don't think it'll be any surprise to anyone that U.S. power consumption this year is expected to reach record highs. But more specifically for the average consumer and the average enterprise, what comes with it is electricity price hikes, which have seen an increase of over 267% over 5 years. This is specific to Virginia, where a lot of these data centers are getting built out in North America, but also relates to other places worldwide. More concerning, though, is that power is actually the capacity of power is expected to grow by 30x by the time we reach 2035. And from a utilization standpoint, we're looking to actually generate 326 terawatt hours of electricity demand, and with it, 100 metric tons of carbon dioxide, which is equivalent, when you look at that growth, of roughly 30 million homes, or today, 22% of the US. Now, to combat this, US electric companies are going to spend over $208 billion just this year, and more than $1 trillion over the next 5 years to drive increased capacity into the power grid. So, look, big AI's tech boom is pushing hyperscale energy demand to historic highs. And that's really what we're going to dig into today. But I just want to provide a little bit of context. All of us are using these chatbots every day, whether it be Google, whether it be Anthropic, whether it be ChatGPT. And the reality is, Google actually just announced that a typical text query in its Gemini app, so anything from a recipe to helping to rewrite a document to helping to produce a nano-banana new video, produces about 0.24 watts of electricity. A typical query. That's the same as running a microwave for 1 second. But then think about how all of these queries, or how many of all these queries there are. Well, there's roughly 2.5 billion queries to ChatGPT every day. So if you take those numbers, and I'm relating Google to ChatGPT here, the power consumption of processing 2.5 billion text queries in a day is roughly equivalent to powering 20,000 typical American homes. So we're all kind of going gaga over this new technology. We're using it for all sorts of stuff. But Don, what are your high-level thoughts? Like, ultimately, what is happening here in terms of us putting pressure that we didn't anticipate on the power grid?
Yeah, Shawn, there's really a lot going on in this space. You cited just the chat queries and so forth, but I think the problem actually is going to get even more complicated as we move forward with Anthropic, or Agentic, use that kind of eliminates us from having to sit there and type queries, and they'll just go off and do its own thing. You'll give it a complex task, it'll go about its business over the course of a day, and may run thousands or millions of queries to get an answer for you. And I believe in one study from the MIT Technology Review said that those types of queries could take up to 43x the amount of energy that just the simple ones that we're doing today represent. So we really have in the very near term some increasing demands just from AI. And also another part of that challenge, Shawn, and without going into too much detail, is the type of model that's being used, how many parameters it has, how complex it is, will dictate how much energy is used during the inference, or when inferences are made using the model. So, as the users, as consumers, we don't have any visibility into how many parameters are in the Google model, the Gemini, Llama, GPT. We just don't have any idea. So we have no way to judge, am I using too much energy? Am I using only a little bit? None of that's made obvious to us. And, there's some challenges there that I think, we as a society need to solve. We need more transparency, I think, in that space to answer some of these energy questions. So you're hitting on all the right points, I guess. Here, it's a huge challenge from an information availability perspective, and from just a power grid perspective, where our grid isn't set up to handle the types of energy demands that will be heading our way, in the next 2 to 3 years.
I love what you said there, and I want to get to the energy grid in a moment. But I just want to kind of hit on a few points. So you talked about agentic AI, and you talked about AI agents coming in and replacing people or augmenting people or making people more productive, whatever way we look at it.
Right.
And it's funny because humans actually consume energy as well. We call it food, and we need food. And every human that we add to the organization, or every human we add to the workforce, theoretically, consumes more energy, requires more food. And we've built a whole agricultural society over the years to deal with that. Relating it a little bit more to consumer, when you go into an electronics store and you go to buy a particular appliance, there's actually a sticker on it that says, if you're going to plug this in your house, here's what you can expect to consume on a daily basis, putting this into your grid. But when we go to the chatbots today, there are no such stickers. Nobody's telling us, are you aware that this query that you're about to run, that maybe you already know the answer to and maybe you don't, is actually going to cost a certain amount of money or power globally?
Right.
And maybe that blindness or that lack of transparency is driving adoption, which is good for these companies, but it's actually putting and making the strain, much more severe over time. So you've given me a ton to think about in terms of, are we, before we go in and typing that query, are we actually thinking about the fact that this query is taking electricity? This is
even Shawn, the time of day that you run the query matters. In California during the day, their energy grid, the carbon intensity of their grid in California is actually very low. I think the numbers showed almost near zero. So during the day when solar is abundant, things are great. But if you're at home doing a project at night, the grid mix actually changes at that time of day. So even when you run your query, where it gets run, if you're asking your phone to run a query for you, you have no idea where it's run. All those things factor into this lack of transparency that we have today that really, again, presents a significant challenge around energy use in AI.
Yeah, so let's shift our focus to the grid. So, AI scaling path, where we're building everything today, assumes that we have infinite access to compute and energy. And by the way, on a long-term view, we will find new energy sources and we will find new ways to kind of generate power. But the fact is today, the grid can't keep up. Electricity companies were struggling before, right? We've had rolling brownouts and even rolling blackouts in countries for years, long before AI. But this problem is going to get worse. And the impact actually extends down to consumers. We're talking about basic heating systems, basic cooling system. Remember, we all share the same grid, right? We're all sharing the same available access to electricity. And so ultimately, what's happening here? Well, first off, utility companies are reporting major capacity constraints due to hyperscaler growth, right? Data centers today make up more than 90% of the new power. And PJM, one of the largest distributors of this power, expects that by 2030, it's going to make up even more of that power. And ultimately, the ratepayers are projected to pay an additional $9.3 billion in annual capacity market cost because of data center demand. So as the data centers consume more and more of this power, it leaves less available power for consumers, which means ultimately the additional power I need to generate is going to cost me more to get access to, and that's going to pass down to consumers. we've already started to see that. Residential customers in Washington saw bills increase about $21 a month starting in June 2025, half of which is actually attributed to capacity spikes driven by these data centers. And so,
hey, Shawn, just to add one clarification, I think there's also with new data centers coming online, the demands aren't necessarily going to directly impact consumers for some of the very largest data centers because they're deploying what's called behind the meter power, meaning they're providing their own power on site, not even connecting to the grid in some cases. So I think we should kind of temper it with all new, energy that's being required by data centers won't necessarily come from the existing grid. There are solutions that will allow them to bring them online without affecting the grid, at least in the short term, to bridge to that 2035 timeframe when maybe more abundant nuclear, geothermal, and other sources are available. So I just think it's important to call that out so we don't, mislead people into thinking that all new data centers are going to be pulling from the grids that feed homes. They don't have to, and they don't have to be built that way.
So that's fair. Look, we've already seen
there are some options there. I guess
that's fair. Look, we've already seen. Microsoft purchased 3 Mile Island. They intend to use that to power some of their data centers. We've also seen the hyperscalers show some degree of empathy to this problem by also saying, look, if the grid comes under undue strain, we'll take our capacity utilization down. We'll actually roll down our consumption so that this doesn't impact the grid. We've also seen things like gas plants opening up near a lot of these data centers. In fact, I wouldn't be surprised to see a lot of industrial complexes that have perhaps been mothballed actually purchased for data center expansion because they have close access to large pools of power. Think old refineries, sugar factories, grain elevators, a lot of these facilities that may no longer be required being consumed and brought into the mix. And also small modular reactors, or what are also referred to as SMRs, where, ultimately building these up to help handle some of that peak. So it's a bit of a give and take. But remember, Don, to my earlier point, it's not just hyperscalers. The enterprises are just getting into this business. Enterprises are just starting to turn these POCs into production-ready processes, whether they host that on-prem, in a sovereign cloud, in the public cloud. I'm not sure that all of those are going to have a auxiliary access to power.
True, very true. And you're right. I'm talking about the very largest. So for the kind of traditional or enterprise scale data centers, they're very much going to be relying on what's available from the local power company or the local grid. So for those businesses, it will very much be exactly as you said. They'll be competing with local, households and businesses for what's available in the area.
Yeah, and by the way, it's compelling, right? If a particular large hyperscaler comes in and says, we'd like to buy this block of power and willing to prepay for the next 10 years or 15 years and make your financials look very attractive, it's compelling for government organizations.
Sure.
But at the end of the day, you've also got to model, what are my consumers going to need? What are my enterprises going to need? What are my sovereign companies going to need? What are my governments going to need? And so ultimately, let's kind of dive in, right? Let's talk about this energy curve. So the good news is, Don, we're early in this. And what we've learned from previous generations is that when we get into these kind of eras early, whether it's e-commerce, whether it's the PC revolution, whether it's smartphones or the cloud, and now AI, we're not really efficient. We tend to use brute force to kind of solve a lot of these problems. And so whether that's, the GPU farms, the TPU farms, whether that's the billions of queries we're doing and the way in which we're processing these queries and training and retraining and looking at inference and then refinement, the models we have, right? Look, ChatGPT launched, I believe, in 2022. We're now in 2025. We're already on the 5th model. And if I look at submodels, we're probably at the 25th submodel. So at the end of the day, is efficiency going to get us there? Or are you optimistic in terms of thinking that there's enough juice in this lemon that as we squeeze it, we can actually solve this power problem through efficiencies?
Yeah, I think efficiency is going to be part of a set of solutions that are going to need to be brought to bear to solve the problem ultimately. Other things that I was going to call out is, there's quantization being done that again can help a little. Edge analytics, moving the AI to where the data is collected, moving out to the edge, can give us breathing room. But I think we also need to have more thought put into kind of the software that runs the AI. That's where I think the biggest opportunity lies. It's not going to simply just be creating faster hardware. It's going to be software that's power aware, that's looking at things like what time of day am I running something. Maybe I can only run training during the day when it's there's no or there's very little emissions impact, or maybe inferences can only be run at a certain time, or have certain budgets for how long they can be run before they need to be the service needs to be turned off for a certain period of time. That's again kind of extreme, but those sorts of things need to be brought in. I also think, and a lot of folks have suggested that perhaps AI can solve its own problem. Like if AI can be brought to bear on some of these challenges, it perhaps can come up with a solution we haven't thought of yet. So I think it's going to be a combination of different approaches that ultimately solve the problem.
I like that. I like that, Don. AI solving for the challenges of AI.
Yes. I know it's kind of a circular argument, but that it's been proposed. That's one of the ideas floating around out there.
With this, because theoretically, if we were to say, we're already starting to see this with things like key value store cache and being able to kind of cache or predict where queries are going to come in. I think there is opportunities, especially with some of the repeatable industry-based tools. If you see the same query come up and over again, first of all, you can cache it. That's great. But if it hasn't been run, you can actually predict that it will be run. You could run it in a time when it will consume less energy. You could then cache the response to it. And then when the actual question is proposed, rather than running the entire inference, you'll be able to pull that inference from cache. So
it's like query deduplication, or search. Like it's basically dedupe, but for the same query that's been run previously or something similar. It'd be kind of a cool technology. I don't know if we've just invented some new form of deduplication, but
it's interesting. The good news is, having been in technology for 25 years, you always see parallels between what's happened in the past and now. And if we look at search, not every search is done holistically. Searches are cached, right? Searches are predicted. I think we're going to see the same thing with questions. We already know that ChatGPT sees similar questions in probably, 30, 40% of all its queries are around the same topic. And they're very sensitive to a news article or something that's going on or something that's topical. So I think you're on to something there. I like this AI inference dedupe idea. So we'll kind of pull
I think we can make a fortune. So
let's just not put any more pressure on the grid.
I don't think it's a unique idea you and I have come up with, but yes, that's another approach that I think, based on history, maybe is another energy or efficiency or way to introduce more efficiency into this AI query process.
Well, so let's round out the episode with talking about really engineering the fix. So the good news is we got lots of smart people. We got many people working on this problem. But let's talk about where this innovation is going to come from, because I do think, joking aside, there are billion, $100 billion, $1 trillion businesses that will emerge that solve some of these problems. You talked about some of them, but I want to really press on the model optimization, because I think there's a lot of meat here, right? Distilling the models, deduping some of what's going through the models using systems like KV Cache, edge analytics. By the way, edge analytics reminds me a lot of, and I'm going to age myself here, but back when I was a high school student, we had this thing called SETI, the Search for Extraterrestrial Intelligence. Right. And essentially, long before, we worried about edge device security and all those things, we would actually give up the idle cycles of our PC to help look at pieces or parses of signal coming out of space to see whether or not they could be interpreted. And we take that sort of work package, our computer would work it, and then it would send the solve back to SETI. I'm not sure if we ever found any alien activity, but
Yeah. I think I came in a little bit later when it was Bitcoin mining that worked that way, where you could do, in your spare cycles, you could mine coins back when, it didn't take a Cray supercomputer or whatever to
Well, that's
find
really
a
interesting, because
coin.
if I take these smaller work packages and I use them on a more efficient device, be it an iPhone, a PC, or any smart device,
Sure.
I actually can solve the same problem without having to use the biggest, most brute force engine to do it. And I think you're absolutely onto it. We've seen it in Bitcoining with proof of work. I think we'll now see it with AI. You could potentially even get a check every month for the amount of work that you did for someone else, providing we can solve for all the security and everything else. Or a company could use all of its assets globally, 6,000 employees, 25,000 employees, 100,000 employees. When they're sleeping, the company could actually use their spare capacity of the assets they own to do work relevant to that enterprise. Let's talk about hardware design. So, today we're architecting for brute force. We're architecting for the fastest, baddest GPUs that we can make. But the answer I would have is, what if we architected those chips for power efficiency? Kind of like what ARM did in the device space, rather than architecting just for pure brute force. Do you think that's realistic?
I do. One thing I want to call out, I heard recently, I was in Texas at the Texas Advanced Computing Center, and they were talking about limits to AI or the GPU design and the fabrication process. Seems like it's going to hit a dead end at 3 nanometers. But so again, it would limit how efficient, or how small we can shrink things. That's kind of been the free lunch, so to speak, of GPU and CPU design, as we can keep going to smaller and smaller processes and doing things. But I think we're going to hit a limit there. But an interesting side path I've heard about is something called magnetic transistors that actually use the magnetic properties of different materials to I guess, transport things at a very small scale, very energy efficiently. So again, falling onto what you're saying, I think we can certainly make the GPUs far more energy efficient. There are competitors to NVIDIA out there that actually market on having GPUs that can provide the same level of performance at a 30 to 50% less energy consumption. Obviously, these competing GPUs don't have all the functionality, can't do everything that the NVIDIA GPUs do, but they can kind of match their performance in the vast majority of activities, and they can do it at a reduced energy footprint. Again, what I saw was anywhere between 34 and 50% less energy for equivalent queries.
Yeah, this is
so hardware. So hardware improvement, I guess, is definitely there's plenty of the runway there to make GPUs that are more energy efficient. Sure.
I love that example you used, using magnetic energy as opposed to electric energy.
Yeah, magnetic transistors, right? And so you're no longer you're able to go almost down to the atomic level where the electrons are flowing across things, and do it in a very energy efficient way. Because right now, the way we're doing it with silicon, there's lots of lost energy. There's limits to how small we can make things. So again, that's going to run out, and we have to come up with a more, a way to get smaller, faster, and more energy efficient. And again, I'm referencing MIT's tech news articles for the magnetic transistors that they've recently started talking about, and they really look promising. But I'm sure it's again quite a ways out in the future.
Yeah, I think we talked about a whole bunch of really interesting things here. I don't doubt, by the way, eventually we'll solve for 3 nanometers, but kind of reminds me of when you bought a new PC every year and you got more and more gigahertz. And then at some point you kind of realized, hey, I don't actually need any more gigahertz.
Right.
Now, of course, we built, more sophisticated software over time, but then it really became, okay, how power efficient can I make these things? And when you looked at something like an iPhone, it was, how long can I have the battery life last without the phone getting too hot or it being exposed to direct sunlight? I think this energy piece is going to be the next phase of evolution. And I do think NVIDIA will play there. I think there'll probably be some sort of power efficient GPU, and there'll be some sort of, performance focused GPU.
Right.
But look, I want to reference our audience to a paper out there called Sustainable Grid Through Distributed Data Centers, which is really a pretty interesting proposal around shifting some of these jobs that are going to stabilize the grid. So we're talking about arbitrage, talking about moving workloads around to where there is spare energy. And, there's all sorts of data sovereignty and other concerns in here. But I think that's really, really where we're going to see some of this move, as well as, accelerating R&D. You talked about quantum. You talked about, magnetic technologies. There's also battery chemistry, there's carbon capture. But ultimately, I guess what I want to end with here, Don, is how should customers think about this? I mean, ultimately, what should they stop and what should they start as they're thinking about this problem today and how they're going to kind of make sure that energy is a sustainable, or electricity is a sustainable asset for them moving forward?
Again, I guess what customers really need to focus on, again, is getting, number one, getting better transparency into how AI, is actually consuming energy for their particular business application or use. Like they need to make, they need to have a metric that measures when they run a query, when they run their AI model, how much is it costing per query, and then kind of, optimize how they're using AI based around that. I think that would be an important aspect to look at. They also need to maybe look at the other infrastructure that surrounds these GPUs. GPUs also require a tremendous amount of CPUs. They require storage. They require network. Those are all areas that can be optimized that use less energy, like moving away from, and again, not to, hit on Pure too much, but moving away from hard disks, moving to an all flash solution can dramatically reduce energy that can then, for storage, that can be redeployed or repurposed, if you will, to run the GPUs and CPUs in a data center. So there's other, knobs that business or IT operators need to be aware of beyond just looking for, the latest and greatest hardware that, runs the fastest queries or biggest models.
Yeah, I like that. So, with Don, let me bring us to our closing thought. I think today we had a really good discussion about where we're at. Let's just kind of level set. We're early. And the good news is we talked about a lot of ways that we can overcome some of these pressures. But the fact is, what we've learned from the last tech eras is that we've learned to manage latency. We've learned to maximize performance. We've learned to maximize throughput. We've even learned to minimize cost through competition. But this power frontier that's ahead of us is going to demand that we learn and understand and focus on the optimization of watts, the optimization of power, real power efficiency. Right. If we fail, we will collectively fail. And the grid will not be silent. It'll push back and we'll feel really real human consequences. So hopefully this is top of mind for everyone out there. And Don, anything you want to leave the audience with in terms of where they can find you if they want to learn more, and we can close out the show from there.
Sure, and yeah, for anyone wanting to reach out, I can be reached at Don at purestorage.com or via LinkedIn. I'm always glad to connect with somebody there and have conversations or answer questions about Pure's product technology and what our sustainability benefits that we can bring to a data center.
All right. Well, that takes us to the end of the episode. And so for Don Kirouac, I'm Shawn Rosemarin. Thank you all for joining Beyond the High T Headlines, and we'll see you all shortly.